Welcome to another solution video of Mechanics 1. Question 1. A tram starts from rest, u is 0, and moves with uniform acceleration. That means acceleration is constant. For 20 seconds, time is 20 seconds. The tram then travels at a constant speed. Okay, so there is a second stage where speed is constant. Speed means velocity. It says straight lines, we can write velocity or speed, doesn't matter. Constant. What it means, acceleration is 0. For 170 seconds. Time is 170 seconds. So this ends at 20. This will end at 190 seconds. Right? 20 plus 170 more. Okay. Before being brought to rest, so finally there is third stage where v is 0 with uniform deceleration. So acceleration is negative but constant. Okay, of magnitude twice. Okay, so let's call it A1, let's call it A2, and A2 is twice A1. So it reduces its speed faster than it increases in first stage. Okay. The total distance traveled is, okay, total S is 2.775 kilometers. Alright, so since we use meters, let's convert it to 2,775 meters. This is what we will need. Okay, sketch a VT graph for the motion stating the total time for which the tram is moving. So we don't know the third one, but the graph will let us know. Okay, so let me draw the vertical axis and then horizontal axis. So first stage is up to 20 seconds. So let's say 20 is here. Okay, second stage is up to 190, 170 more. So it will be very, very far, 170 up to 190. Now A2 is twice A1. That means it will take half the time to come to 0. That means time here is 20 seconds to reach a velocity v. They're saying v, right? We don't know. So v equal to v meters per second here. So v meters, suppose v is here. So in 20 seconds it reaches v. This is the first stage of motion. But in third, it will take half the time because the deceleration is twice in magnitude as acceleration. So that means I have to take half of this, is almost here. So let's say here. It will reach v again, same level, but it will be steeper. So this time is 200, isn't it? It was 20 seconds, so 10 seconds for deceleration because deceleration is double. And we will connect them with a straight line. And please make, this is a very repeated kind of question which is asked in exams, and this has to be velocity time graph. Okay, do we need something here, something else? Okay, nothing. All right, this is the VT graph. Let's go to the second part. Find the value of v. Okay, so they're saying that the total distance traveled is 2,775. So that means the area under this curve, this whole area, has to be 2,775 meters, right? So it's a trapezium. What is the area of a trapezium? Equal to half first parallel line plus second parallel line multiplied by the height between them. So let's substitute what do we see in the graph. First parallel line, this bottom line we can say, and it is up to 200. 200, okay, then plus, and we know that the shorter parallel line, which is the top line, this one, is from 20 to 190, which is 170. And the height between these two parallel lines is the distance, this one, which we don't know, but It is V, and that we have to find out. And that is equal to 2775 meters. So let's multiply this by 2 to solve this equation. So 2 and 2 cancel. 200 plus 170 is 370 V equal to, this will be 55, this one. So now divide both sides by 370, and what we will get is 370 and 370 cancel out, V equal to 15 meters per second. Found V. What next? Find the magnitude of the acceleration. So acceleration is this one, right? Here we have this situation. U is 0, t is 20, acceleration is, we have to find out, and we know that V is now 15, right? So we can use the formula V equal to U plus 80. V is 15 for us, U is 0, acceleration we want to find, time is 20. So 15 equal to 20A, divide both sides by 20. 15 divided by 20 is 0.75 meters per second square. Question number 2. Okay, they have given some coplanar forces. We have seen such a question many a times in last many exams. So how many are they? 1, 2, 3, 4, 4 forces. Okay, they have given the magnitudes here. Act at a point in the direction shown. Okay, and the system is in equilibrium. That is very common. The different situation here is that P and theta are not belonging to the same line. That may create some kind of issues, but let's see how it does. Let's divide them into their components first. So horizontal and vertical. Vertical is not there, so I'm drawing it. Okay. 4 P newtons is vertical, no need to change it to any component. Other three, this and this, they are inclined forces, we will change them to components. So let's change 20 to 20 cos theta. Wherever we have angle, that component is always cos. Alright, so this becomes 20 sine theta. Now P has an angle here, so this will become P cos 30. And in this direction it will be P sine 30. Okay, what about 3P? 3P is in this direction, it will be cos again, so it will be plus 3P cos 30 again. And upwards it will be 3P sine 30. Okay, so all of them are in terms of components now. Now, since the system is in equilibrium, we can equate the vertical and horizontal forces we just got. So let's start with vertical. In vertical, we have these two forces, so let's add them. 3P sine 30 plus 4P equal to 20 sine theta and P sine 30. Sine 30 is half, so let's use that. This is half, so it becomes 3 times half, 1.5P plus 4P equal to 20 sine theta, and this becomes half again, 0.5P. So let's put this P with other P's. So 1.5 plus 4 will be 5.5P, but when this 0.5P comes to the left, it becomes negative. 5.5P minus 0.5 will be just 5P. It is equal to 20 sine theta. We can divide both again by 5 to simplify the look of this. So 4, not 4, it will be just P. 5 and 5 cancel. So P is 4 sine theta, equation number 1. Horizontal forces now. P cos 30 plus 3p cos 30 equal to 20 cos theta. Yeah? Anything else? 2 on this side, 1 on this side, and that's it. So they are exactly same equation. See, p cos 30, p cos 30. So we can write this as 4p cos 30 equal to 20 cos theta. Again, we can divide both sides by, rather let's evaluate cos 30 first. Cos 30 is square root 3 over 2. So 4p times square root 3 over 2 equal to 20 cos theta. 2 and 4 cancel. So we are left with 2 square root 3p equal to 20 cos theta, and 2 again can be get rid of. So we get square root 3p equal to 10 cos theta. Now, whenever this is question number 2, whenever we have two equations in terms of sine and cos, always divide the equation with sine with equation by the equation with cos. Okay, so let's do it. Equation 1 divided by equation 2, and the reason is, I will let you know very soon, equal to 4 sine theta, divide by left side and right side by right side. And this was the reason. P and P will cancel out. We will be left with 1 over square root 3. And 4 and 10 cancel out. And sine over cos is 10. It becomes 2 over 5 tan theta. That was the purpose. Sine over cos is tan theta. That identity helps us to isolate theta here. So I'm converting it to this format first. Now, let's isolate tan theta. 5 and 2 goes there by cross multiplication. 5 multiplies here and 2 multiplies here. Let's find theta with this. Theta will be tan inverse 5 over 2 square root 3. Let me use my calculators to find this angle theta. By the time I do this, I would request you to subscribe to my channel, like and share this video with your friends so that they also get benefited, and I'm motivated to make more and more such videos for you. I'm making this video on demand of one of my latest subscribers. So please, you can also demand any solution video you want, and I will surely prepare it. Thank you. And when I use my calculator, I got 55.248, which I will round off to 3 significant figures, 55.3 degrees. All right, second job is to find P, and we can use any of the two equations we got. Let me use the first one, P equal to 4 sine theta. So let me write P equal to 4 sine 55.3 degrees, and that comes out to be 3.29 newtons. Okay, let's go to the next question, number 3. The particle of mass 2.5 kg is held in equilibrium. This is the best part. Equilibrium, that means it is not moving at all, on a rough plane inclined at 20 degrees to the horizontal. So the weight of this particular particle will be 25 newtons, 10 times its mass. Okay, it is 2.5 kg multiplied by 10, the gravitational acceleration, we get 25 newtons as the weight. So the effect of this weight in this direction, which will try to bring it down, will be 25 sine 20 degrees, because the angle is 20 here. So if this force is bringing it down, what is stopping it? Because they said it's a rough plane, that means the frictional force, let's call it F, is stopping it, and that's why it is in equilibrium. Okay. Force of magnitude T newtons, making an angle of 60 degrees. Okay, now this is an external force which is trying to stop it along with the friction. Not only the friction, this force is also trying to stop it. All right. with the line of greatest slope of the plane. Okay, the coefficient of the friction between the particle and the plane is 0.3. Mu is 0.3. Okay, find the greatest and least possible. Okay, this exam paper looks repetitive. These kind of questions are repeatedly asked in exam. Okay, so let me repeat what I've done in my past videos. First, we'll talk about the least possible value of t. So first, we will write the component of t in this direction, which will be t cos 60 degrees, because angle is here. This component is going to be 60 degrees. So what will be the component here? 90 degree to this. T sine 60 degrees. All right. So now we have to write an equation because it is an equilibrium. Before I explain greatest and least, let me tell you some concept. The component of its weight here is 25 newtons. Okay. It has nothing to do with our question. Okay. I'm just making up these numbers to make you understand what I'm doing here. And 20 is the component of the T force in this direction, and 5 is the force of friction, and they balance out. See, 25 and 25. Now what happens? If we increase, we want the greatest force, right? If we increase it 21, what happens? It becomes 26 above and 25 below. That means this particle will tend to move in upper direction. But friction always joins the weaker force. In that case, what will happen? Friction will join here, and there is no friction anymore here. We have 21 here and 30 here now. So we will have to put a force 9 newtons more to keep it steady, keep it at equilibrium here, so that 21 plus 9 becomes 30, and this is 25 plus 5, 30, right? So there is a range from what was the least one? The least one was 20, and the greatest one is 30. Yes, there is a range of 20 to 30. This particle will still be at equilibrium. This is what greatest and least force is all about. And we are focusing on least possible. It will be least possible when friction and this force applied by us is equal to the force which is downward. Then only it will become in equilibrium, and this will be the least, because frictional force is reducing it to least possible force. So T cos 60 degrees plus F is equal to 25 sine 20 degrees. Now we have to evaluate F also. The F frictional force is mu times R. Mu is given 0.3. Reaction force, normal contact force, is in this direction, which will be in addition to T sine 60. Okay, so first we have to find R, then we can proceed with this equation. So we have to see that the component in this direction is 25 sine 20 for this weight. The component in this direction, which is perpendicular to the surface, is 25 cos 20 degrees. Always they are fixed. This is cos, this is sine, never interchange them. Okay. So now to find R, I have to say that R plus sine 6, T sine 60 is equal to 25 cos 20. Because in this direction also it is in equilibrium, right? And that will give us R. So let's write R equal to 25 cos 20 minus sine 60 is square root 3 over 2. So let's write square root 3 over 2 T. Okay, and let me finally write the value of R by evaluating this, and this is already evaluated with my calculator. I got 23.5, almost, it was 49, so I rounded it to 23.5 and minus square root 3 over 2 T. And I will use that here now. So cos 60 is also 0.5 or half. Let's write half T, okay, plus the frictional force, which is mu R. Mu is 0.3. R we just found out, 23.5 minus square root 3 over 2t, and this is equal to 25 sine 20, which we got as 8.55. So now it looks complicated here. Let me clearly do this in lower part of this screen. So this is 0.5t. 0.3 times 23.5 will be 15, 0, 7.05. Okay, minus 0.3 times, let's write it like it is. It is equal to 8.55. So, do we have a t here? We have a t here, we have a t here. Let's keep these two here, and 7.05 comes this way. So, I will write only the numbers in front of t, and I will write t later. 0.5 minus 0.3 square root 3 over 2, and I'm writing t after this because both of them have t, and this 7.05 will come here. 8.55 minus 7.05. Now we have to evaluate again this part and this part. This part is easy, it is 1.5. Let's see what is this, which is about 0.24 t. There are more digits after this, but I am writing like this. But in my calculator, I'll keep those digits so that I get my answer as close as possible. Okay, so I divide both sides by 0.24. So t will be 1.5 divided by 0.24, and what I'm getting is 6.26 Newton is the least force. But we have found just the least. What about the greatest? Now, so basically in this case, the equation will remain same, the whole of it, only the frictional part, which is mu r, becomes part of the other force, which is downwards, and that will make your applied force as greatest force. So let me rewrite the equation which I started here. Let me copy this one. Right. So the equation remains same, only that the frictional part, this one, comes with 8.55 now. So 0.5t remains there, is equal to 8.55, which was on the right side already. This frictional force also joins it, 0.3 times 23.5 minus square root 3 over 2t. Alright, so 0.5 t equal to 8.55. This times this was 7.05 minus 0.3 square root 3 over 2t, and this will go here with t to become 0.5 plus, it will become plus when it comes here, 0.3 square root 3 over 2, and both of them have t. I'm writing it outside. Together they will be 15.6. So now t becomes 15.6 divided by this whole thing, which is 0.5 plus 0. Let me write 15 square root 3. I cancelled 2 with 0.3, it becomes 0.15, which is 20.5 newtons. Question 4. Small smooth spheres A and B of equal radii and of masses 4 kg and 2 kg respectively lie on a smooth, okay, horizontal plane. Smooth horizontal plane means there is no resistance to them. Initially B is at rest, okay, so let's call it initially, right? UB is equal to 0 meters per second. And A is moving towards B with a speed of 10 meters per second. So UA is 10 meters per second and A is going towards B. After the spheres collide, okay, they collide, A continues to move in the same direction but with the half the speed of B. So then after collision, both of them move in the same direction, and this is the relationship. VA is half of VB. That means VB is faster. Okay, find the speed of B after the collision. All right, so we know by the conservation of momentum, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. m1 will be for A, it is 4 kg. u1, its initial velocity is 10. m2 is 2 kg and it is stationary, but after collision, m1 is 4, still the mass is same, but the velocity is half of v2. So let's call it v2 divided by 2, and m2 is 2 kg, it is moving with v2. Alright, so since both of them are v2, now we can cancel 2 and 4. So it becomes 40, and this is 0, I'm not writing that. It will become 2v2 plus 2v2, which is 4v2. Divide this by 4, divide this by 4. v2, which is the velocity of, final velocity of B, is 10 meters per second. Let's see what are they saying. Find the speed of V, and we got the speed of V is 10 meter per second. That means velocity, final velocity of A will be half of this, 5 meters per second. But it is not asked, so we are not mentioning it. A third small smooth sphere C of mass 1 kg. So mass of C is 1 kg with the same radii, okay, as A and B, is at rest on a plane. So UC is 0 meters per second again. B now collides directly. After going at this speed, it collides. So UB in this case is 10 meters per second. Okay. After this collision, B continues to move in the same direction again, but with 1/3. Okay. So VB is 1/3 of VC. Okay. Show that there is another collision between A and B. Okay, mind it. A is still moving with 5 meters per second, which was not asked in previous part, but we should keep in mind that the body A is still coming towards them at 5 meters per second. That means it will collide with B if B moves with slower than this speed, so that it becomes faster and collides with B, which is slower. All right. So let's try to use again conservation of momentum. So MB UB plus MC UC will be equal to MB VB plus MC VC. All right. So M is 2 kilograms. Its speed was 10 meters per second, with which it was coming towards C. But C, which was 1 kilograms, was at rest. After collision, the mass of B is still 2, but its speed is 1/3 of VC. And then MC is 1 kilogram and it is moving with VC speed. So let's take VC here, add them. It is 2/3 plus 1, which becomes 5/3. 2/3 plus 1, because 2 times 1/3 will be 2/3, and this is 1. We add them, it becomes 5/3 VC equal to 20. So to solve this, let me move it here. So 20 times 3 divided by 5, cross multiply, right? 3 multiplies here, 5 divides, equal to VC. This gives us the speed of C, body C. 5 times 4 is 20, 4 times 3, 12 meters per second. But we are not concerned with the speed of C, we want speed of V. So VB is 1/3 of speed of C, which is 12. So 4 meters per second. And since 4 meters per second is less than 5 meters per second of A. This is the speed of A. This is the speed of B. Okay, there will be a collision between A and B. C is very fast, 12 meter per second. It will not be part of that collision. All right. A and B coalesce. During the collision, they become one body. Find the total loss of kinetic energy in the system due to these three collisions. So let's write the kinetic energy initial. Initial means at the starting of this whole incident, only body A was moving. So only ball A. Okay, so it will be half m for ball A was how much? 4 kg. Speed was 10 meters per second square. So it cancels, which is 200 joules. This was the energy initially. Other two were stationary. They didn't have any kinetic energy. But kinetic energy final, what happened? Let's say for A, what was the kinetic energy for A? It was coalesced with B, so both of them became one body. So it will be half mv square. I hope you understand that kinetic energy is half mv square. This is what I use here, half mv square. Here I will write what is the total mass of A and B, 4 plus 2. What is their speed after collision? We don't know. So let's find that speed first and then we'll come back here. Okay, again, the conservation of momentum, right? So m1 u1 plus m2 u2 equal to, but now in this case both of them became same. So m1 plus m2 and whatever was their speed, right? m1 was the body A, which was faster. So 4 was its weight, mass, and u, initial velocity was 5 before collision. And m2, the body B, it was 2 kg and it was moving with 4 meters per second. And total mass of the two is 6, and we want to find what was their speed together. So it was 20 plus 8, okay, equal to 6v. Divide this by 6, divide this by 6. So v comes to be 28 over 6 or 14 over 3 meters per second. This was the speed of the two bodies together, and we'll go back here. So we want half mv square, and we got 14 over 3 as the final velocity of the two bodies A and B. Now we want C also, because it is also moving. Half, its mass is 1 kg, its speed after that collision was 12 meters per second. So let's see, it should be less than 200 joules, this total sum. Let's see, 4 plus 2 is 6, so 2 and this cancel out, okay. 3 times 14 square will be 196, divide by 3 square will be 9, 3 and 9 cancel. So 196 over 3 plus half times 12 square is 144, which will be 196 over 3, and this cancels 72. Okay, so shall we do it? Yes, let's do it. 196 over 3, and that will be 216 over 3. That comes out to be how much? 6 plus 6 is 12, 9 plus 1, 10 plus 1, 11, 2 plus 2, 412 over 3. This is the new kinetic energy, total kinetic energy of three bodies. So loss in kinetic energy will be kinetic energy final, rather initial. If we are saying loss, that means the initial was more. Kinetic energy final. Initial was 200 joules, we found it, minus 412 over 3 joules. And 600 minus 412 over 3 joules. If you are not comfortable with the These kind of calculations, just put in your calculator, you'll get your answer. 188/3 joules. This was the loss in kinetic energy in the whole of 3 collisions. Next question is here. A car of mass 1250 kg moving on a straight line, okay, straight road. On a horizontal section of the road, the car has a constant speed. This is important word here, constant speed. 32 meters per second, and there is a constant, okay, resisting force. Calculating kilowatt, the power developed by the engine of the car. So power is force applied by the engine multiplied by the speed it is going, and since the speed is constant, it remains same, right? 32. And power we have to find out. We don't know what is the applied force, but since they're saying constant speed, whenever speed is constant, that means acceleration is 0, and we know that ma is applied force minus resistive force, correct? If acceleration is 0, this whole net force becomes 0, and that means applied force is equal to resistive force. So whatever resistive force they have given, that becomes applied force, and we can use 750 here. So power becomes 750 times 32 meters per second, which is 24,000 watts or 24 kilowatts. Okay. Next, second part. Given that this power suddenly decreased by 8 kilowatts, decreased by, so it was 24 kilowatts, now it is 24 minus 8, 16 kilowatts, which is 16,000 watts. That's what we will use. Find instantaneous deceleration of the car. Instantaneous means suddenly it changes. That means it was moving at 32 meters per second. That remains 32 meters per second for that moment, that one moment. Okay. So since power is known to us, velocity is known to us, can we find applied force? Of course, by the same relationship, power over speed is applied force, right? So power is 16,000 divided by 32 equal to how much? 500 newtons. This is the applied force. Now we'll use the same thing again, the equation we've been using for a long time. Ma is applied force minus resistive force. Mass is 1250 of the car. Acceleration we want to find out. Applied force is now 500, and resistive force remains how much? 750, right? So let's finish this here. Acceleration will be 500 minus 250 is minus 250, 500 minus 750 divided by 1250. So that comes out to be negative 0.2 meters per second square. That's the momentary instantaneous deceleration. Okay. On a section of the road inclined at sine inverse 0.096. Okay, so if this is the inclined and this is angle alpha, so they're saying sine alpha is 0.096. That's what it means. Sine inverse 0.096 means the angle is of sine inverse 0.096. We can interpret it like this. All right. The car travels up the section of the road at constant speed again, with the engine working at 60 kilowatts. So power is 60,000 watts. Speed is constant, and that speed is V. All right. So we will use again the same formula we used in the previous part also. Ma equal to applied force minus resistive force. Applied force will be the power 60,000, one extra zero, 60,000 divided by the constant speed, right? That is applied force minus resistive force is given 1000 plus 8V, 1000 plus 8V. And there will be one more resistive force because this is the car, its weight is 12,500 newtons, 10 times its mass. There will be a resistive force because the car is trying to go up. There is already a resistive force Fr we have been given, but there will be a component of its weight which will also resist this car to go up, and that will be 12,500 sine alpha, and sine alpha is 0.096. We'll use it in our equation. 12,500 0.096 is equal to 0 because acceleration 0, so ma becomes 0, so I'm writing equal to 0. I'm not writing anything else. Alright, v is a denominator here. Let's get rid of this v by multiplying the whole equation by v. So when v multiplies with this one, this v gets cancelled out. We are left with 60,000. Yeah, minus this v multiplies with both of them. It becomes minus 1000 v minus this plus and this minus will make it minus, and 8v multiplies with v, 8v square. So when we multiply v, it multiplies with both parts of this because they are adding. If they are multiplying, we would multiply only once, but they are adding, so we are multiplying with both. Minus 1250 and times this will be 1200 v. Okay, because v is multiplying here, and together if they multiply, we get 1200 v, which is equal to 0. Now it becomes a quadratic equation. Minus 8v square 1000 and 1200 minus 2200 v and plus 60,000 equal to 0. And now we can use factorizing method for this. I can use factorization. You can use your calculator straight away if it is capable of, but it is worth 5 marks, so it's better to show it. So 8v square minus 2400v plus 200v plus 60,000. I broke this minus 2200 into two parts so that I can get something common here, which is minus 8v, v plus 300 plus, because minus is already out, okay, plus 200 v plus 300 equal to 0. So we get two factors at minus 8b plus 200 and v plus 300 equal to 0. So we get from this, we get minus 8v equal to minus 200. So v will be minus 200 divided by minus 8, which is 25 meters per second. And if I take v plus 300 equal to 0, that will give me a negative speed velocity, which is not the case because it is moving in the forward direction only. It is not moving in the backward direction. So this is not the answer. 25 meters per second. This is the only answer for this particular part. Question 6. A particle P moves in a straight line. Okay. The velocity v is given by these three equations from 0 to 5, 5 to 7, 7 to 13.5. Okay. Sketch the velocity time graph. Okay, so for velocity time graph I will need grid. So let me draw v-axis and t-axis. Okay, so this is v, this is t. Let's focus on the first equation, which is from 0 to 5 seconds. So since it is up to 13.5, so let's say 5 is up to here, and this is 0. From 0 to 5, it's a linear graph with the v-intercept as 1 and gradient as 2. You remember this, y equal to mx plus c. That is the equation of a line. It is exactly similar. C is the y-intercept. In this case, 1 is v-intercept and 2 is the gradient. Okay. So first, let's mark the v-intercept, let's say 1 is here. That becomes v-intercept. So your line starts from 1 and your gradient is 2. That means if your run is 5, your rise has to be 10. Then it becomes a gradient of 2, right? Because we know gradient is rise over run. So 1 plus 10, we need 10, right? So 11. So 11 meters per second, at 5 seconds the speed reaches at 11 meters per second, and this becomes the equation of y equal to 2t plus 1. Gradient is 2, rise over run, and v-intercept is 1. This is the first part. Alright. V equal to 36 minus t square. It is a quadratic. That means the curve will be a curve, but 5 to 7 is a very short period. So let's say 7 is here. Okay. So we have to show that curve between 5 and 7. So 6 is there. So let's make a table. That will be easier to do. So if t is 5, what is v? So in place of t, put 5 here. 5 square is 25. 36 minus 25 is 11. And yeah, it is 11 at 5. We can see that. 6. 6 square is 36. 36 minus 36 is 0. So we have 0 here at 6. 7. 7 square is 49. 36 minus 49 minus 13. At 7 seconds, the speed is minus 13. So graph will be, if that is 11, let's say minus 13 is here. So we have to make a curvy kind of graph between 5 and 7. Let me use a curve. That's it. It will be a curvy kind of graph till 7 seconds. Alright. Now the third equation is v equal to 2t minus 27. That means minus 27 is the t-intercept, which is very, very below this, somewhere here. I'm not going to draw that, but I know that the gradient is 2, and at 7 seconds definitely it is going to be minus 13. Let's put the values here and confirm. 2t minus 27 at t equal to 7, it will be 2 times 7 minus 27. So 14 minus 27 minus 13. See, we are at minus 13 meters per second here. That's fine. So that means we have to draw a graph from here, and the gradient is 2. Can you see? Gradient is 2 again. Y equal to mx plus c, that kind of thing. So how can we have gradient? 2 over 1. But our the graph has to be till 13.5. From 7 to 13.5, let's say 13.5 is here. 13.5. And let's put 13.5 into this equation, which will be 2 times 13.5 minus 27. So this is 27 minus 27, 0. That means our graph has to stop at 0 meters per second, and it will be a straight line again. So let me draw a straight line. This is the graph. This is a straight line, this is a curve, and that is a straight line. This is how our VT graph will look like. B part says find the acceleration at the instant when t is equal to 6. So basically what they're asking you to find the gradient of the tangent at this particular part, this gradient of this tangent, right? And how do we find gradient of a tangent? Just differentiate the equation of the curve, but it is not dy over dx this time, it will be dv over dt. That will give us acceleration. We differentiate this equation, this one. That one is applicable, right? 36 minus 2t, sorry, t square, 36 minus t square. So v is 36 minus t square, dv over dt will be 0. The differentiation of 36 is 0, minus this will be 2t. Okay, so now the gradient of the curve at t equal to 6. So at t equal to 6 dv over dt, which is acceleration, is minus 2t. So minus 2 times time is 6, minus 12. So acceleration is minus 12 meters per second square at t equal to 6. Okay, and next one will be this. Find the total distance traveled by P in the interval from 0 to 13.5. Total distance, not displacement. Let's find the area of this trapezium first. Okay, I hope you agree that this is a trapezium. This shape. If I find the area of this one, it will be area under curve, right? So, what is the area of trapezium? This trapezium. Let's see. Why area of trapezium equal to half first parallel line, which is this small line, which is 1, plus second parallel line, which is this orange color line, which is 11, and the distance between them, that is the height, 5. So it becomes 1 plus 11 is 12 divided by 2, 6 times 5, 30 meters. So it travels 30 meters in first 5 seconds. The middle one is a curve. We'll take care of that later. Let's find the angle of this triangle now. It's a triangle. It's not a trapezium this time. So area of triangle will be half base. Base is this one, which is 7 to 13.5, 6.5. Height is from 0 till 13 minus 13. So I'll take it as positive 13, okay? Because we want to find the area. Area cannot be negative. So I'll not take it minus 13. I'll take the height as 13. So 2 and 13 again cancel out. So 6.5 square actually, which will be 42.25. Now left is the area, this one, and this small area, this one, which we will find by integration of 36 minus t square. Let's do it. So integration of 36 minus t square once. It will be from 5 to 6, right? Yes, it is 5 to 6 and 6 to 7. So 5 to 6 dt plus 6 to 7 and same curve again. It is in two parts. I'm breaking it in two parts because there is a fact that this area will be positive. This area, because it is under t-axis, it will be negative. And if I add them, we'll get the difference of them. That's what not we want. We want both the areas. So that's why I will add them and put an absolute around this one, because this is going to be a negative area for sure. Let's do it now. So 36, integration of 36 is 36t minus t squared integration will be t cube over 3 plus c from 3 to 5 to 6. It is not 3. 5 to 6 plus same 36 t minus t cube over 3 plus c from 6 to 7 absolute. Alright, so let's substitute the values now. 36 times 6 minus 6 cube over 3 plus c minus 36 times 5 minus 5 cube over 3 plus c plus 36 times 7 minus 7 cube over 3 plus c, and shall we put up, let's put up minus c, minus 36 times 6 minus 6 cube over 3 plus c. Alright, now 36 times 6 is 216 minus 216 over 3. Let's cancel the c, all the c's, so that they don't confuse us. Okay, minus, not plus, it will be minus. 36 times 5 is 180 and this minus will make it positive. 125 over 3. Okay, now plus absolute sign still stays 36.7252. 36 times 7, okay, minus 7 cube is 343 over 3. And now this minus 36 times 6, 216, and minus, is it minus? No, it is plus 216 over 3. So I got 17 over 3 for this one, and here we got minus 19 over 3. So if we apply absolute, it becomes 17 over 3 plus 19 over 3, which is 36 over 3, and 36 over 3 is 12. So let's see what was the area of the other two, which was the distance. The first area was 30, then 42.25, and now we have 12. We will add all of them to find the total distance. So total distance, which is the area under all the curves, is 30 for first 5 seconds, 42.25 for 7 to 13.5 seconds, and now we got between 5 and 7 seconds as 12, which is 7284.25 meters.